Hello guys, we are back with new video that's about types of chemical reaction. In today's video, we are going to discuss about mainly 5 types of chemical reaction. It's synthesis, decomposition, displacement, double displacement and combustion reaction. So without wasting any time, let's get started. Okay, let's start with the first type, that's the synthesis reaction. So in synthesis reaction, what we are going to discuss, very first, what is its definition? It says when two or more elements or combine molecules combine to form a single product, that's known as synthesis reaction. So what's a synthesis reaction? As its definition says, that it's a reaction when two or more either elements or molecule that combines to form single product, that is known as synthesis reaction. Now let's see some examples. For example, if we are combining carbon with oxygen, we know it will form carbon dioxide. Similarly, if we are combining sulfur with oxygen, we know it's going to give you sulfur dioxide. Or you can see if you are combining hydrogen with oxygen, it will give you water. And let's say if I'm combining nitrogen with hydrogen, it will give me ammonia. And if I'm combining ammonia with HCl, then it will give me ammonium chloride. Now let's discuss what we are getting from these. So you may see in the first equation we are combining carbon and oxygen, which is giving you only one product. So this single product get formed by the combination of carbon and oxygen, which justify its definition that says when two or more elements or molecules combine. So here similarly you may see in the case of sulfur and oxygen, you are getting sulfur dioxide, hydrogen and oxygen, which is giving you water. Similarly with nitrogen and hydrogen, you are getting ammonia. And now here when you are combining ammonia with HCl, when you are combining these two molecules, you are getting a compound ammonium chloride. So on this side, what you are observing? You are observing that you are getting only one product by the combination of number of reactants. So this is known as synthesis reaction. Let's go to next. Okay, so as we are having here the second example, in which what is a decomposition reaction? As its definition says, when a compound either breaks down or splits up into two or more simpler forms with the help of energy. Now energy can come to you either in the form of heat or in the form of light or in the form of electric energy. Now let's see few examples. When we are checking the examples with respect to decomposition, what we have to take care, we should have only one reactant because it says a compound. Now let's see, if I'm having the example of zinc carbonate, when I'm heating it, it will give me zinc oxide and carbon dioxide. So now in this case, on the heating of one reactant, I am getting two products. Yes. Now let's see the another example. So in the next example, what we are having, let's say I am heating ferrous sulfate, that is iron 2 sulfate. If I am heating this, what I'm going to get? I'm going to get ferric oxide, sulfur dioxide and sulfur trioxide. Again, what I have observed from this, I have heated only one compound, which gives me number of products. Now let's go to the next. Now in the next example, what we are having, let's say if I'm heating lead nitrate, what I'm going to get? So in this case, when I'm heating lead nitrate, I'm going to get lead oxide, nitrogen dioxide and oxygen gas. So again, what we have observed, we are having only one reactant which gives us number of products. So what is a decomposition? If we will say in simple words, decomposition is a reaction which contains only one reactant, and that reactant will decompose with the help of some amount of energy to give you number of products. Now let's discuss more about this. Okay, let's see few more examples. So if we are having a compound of silver bromide or silver chloride, or you may say if you are having any compound of silver, when you are keeping it in the presence of sunlight, these compounds will decompose. Now let's see what do we get as a product. On the decomposition of silver bromide, we will get silver and bromine, while on the decomposition of silver chloride, we are getting silver and chlorine. So if I'm going to write down in the balance form, it's come to me like this. In this way, if you are good in balancing, that's fine. If you need any help for the balancing, I am attaching the link of my previous video about balancing, where I have done the balancing with easiest method. Please don't forget to check in that. Okay, now let's go to next. So we are having one more example like we have done with heat and sunlight. Similarly, we can decompose the molecules with the help of electric energy as well, or you may say by passing electricity. So if I will pass electricity through the water, I know what it's going to give me. It's going to give me hydrogen gas and oxygen gas, and in the balance form we are going to get it like this. So this is all about the balancing. Now here I am going to give you one additional note. When decomposition takes place with the help of heat, and that time it's known as thermal decomposition, while when the decomposition takes place with the help of sunlight, it's known as photolytic decomposition reaction. And if you will see the last one that we did, when decomposition have take place with the help of electric energy, or you may say with the help of electricity, this is known as electrolytic decomposition reactions. So these are further classification of decomposition reaction. If you find it useful, please keep it, otherwise ignore it. Now let's go to next. Okay, let's talk about the third types, that's the displacement reaction. What it is: when an element displaces the other element from its compound. Which element is going to displace? That should be highly reactive. Now let's see, if a highly reactive, let's say the A has more reactivity than B, then A can take the place of B, and when A is displacing B, it's going to get form. What it's going to get form? It's going to get form AC, and B will get free. So let's see few more examples with regard of this. Let's say if I'm having zinc plus copper sulfate. Now we can see in this, here we are having zinc while here we are having copper, and these upper one are more reactive elements and these lower ones are less reactive elements. So we can see zinc can easily takes the place of copper. So what it's going to be? It's going to be zinc sulfate, and copper is going to get free from the compound. Now let's say if we are having another example, iron with copper sulfate. Now in this case again we are going to check about iron, where it is. It's here, and then again the copper is lying below. So it means iron can easily takes the place of copper. So it's going to get form iron sulfate, and copper will get free. So this displacement is also possible. Similarly, let's say if I am having copper with silver nitrate. Now in this case, let's see. Now when we are checking for copper with silver nitrate, here we are having copper and here we are having silver. So in this case, we can see copper is lying above the silver. So what it mean? It mean here the copper can takes the place of silver. So what it's going to get form? It's going to get form copper nitrate, and silver will get free from here. So just to balance it, I have to write here 2. So this is the way we are going to use this reactivity series to find out which chemical reaction would work or which will not. Now let's go to the next type. Okay, let's talk about our fourth type, that is a double displacement reaction. What is a double displacement reaction? It's a reaction which takes place by the exchange of ions between the compounds. As we know, ions are of two types, cation or anion. So we can do this reaction either by exchange of cation or by exchange of anion. Might be you are good in with cation and anion. Cations are positively charged and anions are negatively charged. Now let's see few examples. For example, if I am having a compound of sodium chloride and reacting it with silver nitrate. Now as here I am reacting two compounds, they will do the exchange of their ions. Let's say I am exchanging their cations, sodium and silver. So now when I am exchanging the sodium and silver, their positions, now what I am going to get after exchanging their position, I will get silver chloride and sodium nitrate. So now in this case, it's time to check their physical state with the help of this solubility chart. This solubility chart explains about the solubility of these ions with some exceptions. Like we can see here that chlorides or other halides mean it can be fluoride, bromide or iodide as well. So these halides are insoluble in these metals, copper, silver, mercury or lead. Now let's check it about this. Here we are having chloride with silver. So we can see chlorides are insoluble in silver. It means this should be insoluble in this chemical reaction. When we will see this chemical reaction in the lab, as a result of this chemical reaction, or you can say as a result of this exchange of ion, you may see silver chloride come to you in the insoluble state. So that's why its physical state is going to be solid. While when we are checking it up for nitrate, we can see for nitrate there is no exception, so it will remain same in the physical state of aqueous. One more thing, if any substance is lying insoluble in the reaction, that is known as precipitate. So here we can say silver chloride form precipitate. And if we are checking the color of precipitate, that would be white. So we can see while reacting sodium chloride with silver nitrate, the silver chloride is going to get form white precipitate. It means white insoluble substance of silver chloride get formed. Now let's see another example. For example, if I am having barium chloride and I am reacting it with sodium sulfate. Now in this case, when I am going to exchange their ions, again their cations from barium and sodium, if I am exchanging their position, what I am going to get? I will get sodium chloride and barium sulfate. So now let's do it. Barium sulfate. Now for this, let's check their physical state. Now very first we are going to check the physical state of chloride. Now we know chloride is soluble with most of the metal ions except these. So here we are having sodium. We don't have sodium in this list. We are having copper, silver, mercury and lead. So it's going to be in aqueous. Okay. Now let's check the physical state of barium sulfate with regard of sulfate ion. So here we are having sulfate ion. Okay, let's change the color. Here we are having sulfate ion. So for sulfate ion, we know they are insoluble with these metal ions. So here I am having barium ion. Okay, so again sulfate is coming with barium, so it's going to form insoluble substance. So its solubility is going to be insoluble, so its physical state is going to be solid. Okay, so as its physical state is solid, which shows that this compound is insoluble in this reaction, it means here it's going to get form precipitate. Now let's check the color of this precipitate. Again its color is white. When you will perform this reaction in your lab, what you will see, you will get the white precipitates of barium sulfate as a result of this reaction. Okay, so our fifth type is combustion reaction. So in which we are reacting oxygen with some sort of hydrocarbon. If I am providing the complete supply of oxygen only on, then I can get carbon dioxide and water as a product. But let's say if we are providing the limited supply of oxygen, then what would be the product? So if we are providing the controlled oxygen, or you can say the limited supply of oxygen, and that time we can get carbon monoxide along with carbon dioxide and water. So here in general, whenever we are talking about the combustion reaction, it means we are talking about the full supply or the complete supply of oxygen, where we are getting the products carbon dioxide and water only. Now let's see few examples. For example, if we are having methane and we are reacting it with complete supply of oxygen, then we would get the product carbon dioxide and water only. Similarly, if I'm having C3H8 and I'm reacting it with oxygen with the full supply or complete supply of oxygen, then our product is again going to be the same. That should be carbon dioxide in water. So that's about the combustion reaction and with respect to all the five types of chemical reaction. If you have any query, don't forget to send me an email. Thanks for watching. Don't forget to subscribe my channel for more tutorials and feel free to send me an email if you have any query.